बिस्मिल्लाहिर्रहमानिर्रहीम। ए लेवल में जो ट्रिग्नोमेट्री का टॉपिक है ये कुछ उसके जो है बेसिक चीज़ें एएस में दी हुई हैं और बाकी A2 में। तो नाउ वी आर डूइंग trigonometric ratios of complementary angles. You know very well that the angles whose sum is 90 degrees, they are called complementary angles. I mean, if there are two angles like alpha and beta, then alpha plus beta is equal to 90. In this case, alpha and beta are known as complementary angles of each other. If their sum is 90. Sum 90 means if one of them is 20 degrees, the other is 70 obviously, then they are complementary angles of each other. If one of them is 30, the other one will be 60. If one of them is 80, the other one will be 10, this way. So, complementary angles and their trigonometric ratios. Let's see. Actually, we have already discussed special angles. Now, special angles were 30, 45 and 60. And this was one of those concepts that if side opposite to 30 degrees is 1, then hypotenuse is 2. This is a simple thing which you need to remember, that if side opposite to 30 degrees is 1, then hypotenuse is 2. Or conversely, you can say that if the ratio of one of the sides and hypotenuse, if that ratio is 1 is to 2, then angle to opposite to 1, that will be 30 degrees. Whenever you draw a triangle, like if I draw a triangle this way, and this ratio is 1 is to 2, then this is 30 degrees. If I draw a triangle this way, and this ratio 1 is to 2, then this angle will be 30 degrees, always opposite to 1. Opposite to 1 is 30 degrees in case hypotenuse is 2 of a right angle triangle. You know, obviously hypotenuse is always there in a right angle triangle. So there is no need to tell that this angle is 90 degrees. Okay. Now, if this is clear, then next thing is that if this is 30 degrees, this will be 90 minus 30. 30 and this will be 90 minus 30, 60. If angle here is 60, then that will be 30. So these are, that means other than this right angle, the two angles in a right angle triangle, they are always complementary. Now their ratios we have already discussed in special angles, that the ratio like sine 30 degrees, sine means opposite over hypotenuse. Opposite is 1 and hypotenuse is 2. Cos 30 degrees, adjacent. Adjacent to 30 is under root 3. So this will be adjacent over hypotenuse. Tangent 30 degrees, that is opposite to 30 and adjacent to 30. So that will be 1 upon under root 3. So this is 1 over under root 3. On the other side, if we write the ratios of 60 degrees, now you can say that the reference angle is 60. Then you can see, I think this is not something difficult to understand, that this time when 60 is the angle, then this value 1 is its adjacent and under root 3 is opposite. In case of 30, it was opposite and this was adjacent. So names of these sides depend that which angle we are considering. If this angle is considered, this is opposite and this is adjacent, and for 60 degrees they are opposite. Okay, then sine of 60 degrees is opposite over hypotenuse, opposite to 60 degrees, and cos 60 degrees, that is adjacent over hypotenuse, and tangent 60 degrees is under root 3. Now you can see that here sine 30 degrees is 1 upon 2. Sine 30 degrees 1 upon 2. These are the ratios of 30 degrees. These are ratios of 60 degrees. And cos 60 degrees is again 1 upon 2. And the reason is that the side opposite to 30 is 1 and adjacent to 60 is same 1. And hypotenuse is common for both of them. So in this case, we can say that sine 30 is equal to cos 60. Value of sine 30 degrees is equal to value of cos 60 degrees. Both are same value, half. And why they are same? Because these are supplementary angles, complementary angles of each other, 30 degrees and 60 degrees, and their sum is 90 degrees. So from here we can conclude that whenever the sum of two angles is 90 degrees, then sine of one angle will be equal to cos of the other angle. So here you can see that if this is cos 60, that must be equal to sine 30, and reason is the same because sum of 30 and 60 is 90. You can see here that cos 60, okay, I have written the same thing here. Let me change the values. We can say that cos 30 degrees is equal to sine 60 degrees. How is it? From here you can see that sine 30 cos 30 degrees is under root 3 upon 2, and it is same for the value sine 60 degrees, again under root 3 upon 2. So cos 30 is equal to sine 60. Now this is not the matter of 30 and 60 only, but if there are some other angles like 20 plus 70 is 90 degrees, then sine of one of these angles, sine of 20 is on one side and 70 is on other side. If I put sine, write sine here and cos here, they will be equal, or cos with 20 and sine with 70, it makes no difference because in both of the cases sine 20 degrees equal to cos of 70 degrees. Sine 20 degrees equal to cos 70 degrees, or you can say that sine 70 degrees equal to cos 20 degrees. Okay. Now, if I don't tell the values of the angles, simply I write sine 25 is equal to what angle in terms of cos? So very easily we can do that if this is 25, what is the value of the other angle? That is 90 minus 25, that will be 65. So 25 and 65. Because reason is the same, 20 and 65, that is equal to 90 degrees. If I use any other angle like cos 35 degrees is equal to sine of what angle? 90 minus 35. 90 minus 35 is 55. Okay, if I write 90 minus 35 instead of 55, so value is same. From here we can make another result, that if the angle value of the angle is not known, this is cos of alpha, one thing at least we know that this will be 90 minus alpha. And what is the reason? That in any right angle triangle, if this is right angle triangle, this angle is alpha, as it is the right angle, then sum of the other two angles is 90, then this angle must be 90 minus alpha, and this is 90 minus alpha. So cos alpha is equal to sine 90 minus alpha. So from here we can make a conclusion that sine 90 minus theta is equal to cos theta, and cos 90 minus theta is equal to sine theta. And third, about tangent. What about tangent? You can see here that tangent 30 degrees is 1 upon under root 3. 60 is under root 3. So how we can relate them? You can find that this is under root 3, this is again under root 3. So how we can define them? That reciprocal of under root 3 is 1 over under root 3, or reciprocal of 1 over under root 3 is under root 3. That means whatever is the angle here, tangent 90 minus theta, that will be 1 over tangent theta. So this way we can define that tangent 90 minus theta is equal to 1 over tangent theta, or you can say that tangent theta is equal to 1 over tangent 90 minus theta. So that is the conclusion of all this discussion. And one more thing I add in it, that if the angles are in terms of radians, in case of radians, you know that angle 90 degrees, angle in degrees, that is equal to pi over 2 radians. So same properties we can write here in terms of radians, that sine 90 minus theta, this is, you can say 90 minus theta, is equal to cos theta. So that is equal to cos theta. And second, cos 90 minus theta is equal to sine theta. There is no difference, only there is one thing different, that we have used pi over 2 instead of 90 degrees. And the second difference is that when we use pi over 2, then theta will also be in radians. Now the theta is not in terms of degrees. In this case, if we write in terms of degrees, then theta is in degrees. Otherwise, theta is in, if we use pi, then theta is in radians. Third, tangent pi over 2 minus theta, that is 90 minus theta, is equal to 1 over tangent theta. So that is the total discussion about uh, complementary angles, trigonometric ratios of complementary angles. So this is what you need to remember. And there are a few more identities like this. So it's better if you practice them and try to remember that sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. If you are not learning the same concepts, I think it is very difficult to remember or understand them for a long term. So try to refer to the figure right angle triangle, that what is the reason that sine 90 minus theta is equal to cos theta, and so on. So that's it for today, and next we will discuss more identities and concepts of trigonometry. So by that time, Allah Hafiz.